Okay, so now I've got a little bit of an update. I've got these guys in place, make this a little bit smaller. Um, so that works quite nicely. I'll explain what the last problem is to sort out over. So we've got something resembling a water bath over here. It's just basically a pump that I printed, bath, and just a metal pipe so that it doesn't stick onto it. So this thing can actually fit nicely onto that area. I'm not sure that's the best idea, but it can do that, right? It's not a lot of water. Unfortunately, the pump is not that strong, but I don't want to push it using more amps. Otherwise these wires might overheat if it gets to 2 amps. So, but in any case, so that's for this side. Over here, I mixed in some used filament. This was a misprint that happened, and it printed a whole lot of these small. My printer printed all these small, like meters and meters of this filament out, and so it can't be reused or can't be printed again with. Because the diameter is too small, so we just cut it up and it's in there. So it's not the best after testing it. You get some much better results, but still, this material is just crap. But in any case, so that's how it looks currently. And then I'm just waiting for it to reach a heat levels, and I'll turn it on to get started. So let's see. So okay, when it's just starting out, there's a lot of cold material in here. So it has this really hard time pushing it forward. So it kind of pushes it forward, and all that molten plastic that's not yet quite fully melted pushes back on it. So it's best to actually let it wait a bit. Or, if you hammer it up, I'll just intensify it a little bit so you can see it jump. Okay, but well, just needs to warm up, and then it will be able to handle that. So again, there's also a diameter sensor that I've built that also goes with this, but I'll wait with that for last. And I don't really think I need it, to be honest. I think you can just measure the diameter, and there's not much you can do. If the diameter is 2 millimeters, you need to get it down to 1.75, roughly in that area. But you can't take like dynamic action. If it goes down to 1.5 and then 1.8, 1.5, jumping like that, then you've got a bad setup over here, and you can't really do much to control, to adjust your speed and so forth to cater for that. So I hope that won't be a scenario here, but so far it doesn't look like that's the case. So you'll see the extrusion gear is not spinning currently, but all that pressure is pushing out a little bit of a molten plastic over there. So I'll start this thing up again. Okay, so let's see. See, those are little air bubbles coming out, but that's normal for the start. Especially after what I've seen is this first bit of plastic, everything that's been in here for a while standing is not that great quality. But it just takes a bit of time to get through it. So, but as you can see, this is not quite black and not quite white, and it's not grey either. It's literally a mixture of all these different colors. So it's got all of a bad still, and just looks different. In any case. So as soon as I need 2 hands, I'll probably stop this video, but for the moment I'll see how far I can get with 1 hand. So maybe I'll 3D print a dolly or something for this camera to stand on, because I know people are not too happy when a video goes like this filter. My apologies. In any case, good. Okay, so let's see. Okay, what I can do, the idea is to get this directly on there, but I first want it to flow a little bit, right? Because that will cool this part quite fast. I'm not sure how good, it's probably not good for the metal to have water touch it directly. But you know, this is experimentation, so. Okay, let's give us a little bit more speed. Okay, so it's not properly warm yet. Let's, you know what, I'm gonna just try this. Okay, it definitely needs to first build up a little bit more pressure and come out here with a little bit more force. But okay, at least that will cool it off for sure. And it should be a little bit more symmetrical, because once you touch it, that water will flow upwards and over the material. But okay, so well, maybe I'll make a second video to this that shows it actually working, because it might take a bit of time to, and also 2 hands, to get this thing working correctly. So I'll leave that for the next video. Looks super tempting. Okay, so then another thing for the future is this water bath also needs to be actually temperature controlled. You know, so that you want, usually what they do is they'll take 2 water baths. You know, or at least the big machines do, is you'll take a water bath that's about 60 degrees Celsius, and then another water bath that's a lot colder than that, and then you need to get rid of the water. But that's just so that this doesn't cool off too fast. You want this to be cooling off symmetrical, but not too fast. So, but in any case, we'll see how this turns out. Okay, so I'll need 2 hands at this point. Okay, so next video I'll make, hopefully I'll be able to show something usable. Okay, so that filament is moving forward. It actually looks quite good. As long as it's not leaking down this side, but you just need to make sure that's nicely sort of sealed and it won't drop off there. But okay, so far I mean, shit, look at that. That actually looks way better than it should at this point. Wow, I'll just let that push through and have a look at that. But that's actually quite pretty. It's way too thick though. That's probably like 3-4 millimeters in diameter. But it kind of looks nice, and I'm not yet doing any pulling and so forth, but I'm just waiting for that material to get out this side so I can actually start pulling. And there's some stuck over here, I'll get rid of it. I don't mess it up now. Okay, so let's get rid of it. Brittle. But okay, that looks quite good. Okay, I need 2 hands at this point again. But let's see how do you know about it. So okay, hopefully this will look quite good once it gets out of here. And now's a good time to pull it. Oh, that feels good. Look, if I pull it, oh, that's quite nice. But okay, this is still very brittle. I can feel it. It's way too brittle. Oh, that thing is getting hot. I might melt my motor. Okay, I mean this is not pulled and this will be a first bit. It will look crappy once it's under this guy's control, but it will definitely look better. I hope so, but I mean when I use the fan and so forth, it definitely, yeah, I mean at this point I'm expecting it not to look too good. But you know, I need to get this diameter down, but I'll first wait for it to get some length so I can actually pull it without breaking it. But it's gonna break in because I can feel it's too brittle. Way too brittle. Okay, so maybe I'll pull with my hand just so that we can see. Okay, so it's long enough for me to get it in there, but I'll definitely need 2 hands to not mess this up. So okay, I've adjusted that thing, it's a little bit smaller now as well, so it will be even more difficult to get it in there. But I mean, this is basically my hand pulling it, so you can see the difference of diameter. This is how it pushes it up without any extra force. And when you're pulling it, you want it to basically pull it at a consistent diameter or consistent force to get it down to a smaller diameter. And you don't want bubbles and things like that to be happening, but that's like I said, I mean I'm using my hand with this. So okay, I'll just take this bit, I'm going to break it off, see how brittle it is. Yeah, so it's not going to go through very nicely, but in any case, it's going nonetheless. Okay, well, let's see, maybe I can do this with one hand. It's going to be hard, but possible. Okay. So look at that. It's probably going to break. It's not going to go through there at all, so I'll have to manage this manually. But other than that, I mean, the puller does its job. I'll just break that off so you can see. Puller does its job. Okay, let's get rid of this. Okay, so I'll need two hands, otherwise that's just going to happen again. So that won't go through that little hole over there. Okay? Okay, so it's jumping quite a lot and I just got it in there. And that's currently outperformed. So I mean, obviously we'll probably need to add some tension to that line. But you don't like that, you don't want that to be happening, but this is just the first bit. Let's wait for it to stabilize to see how it actually turns out. Okay, I can set the micro stepping on this guy to be to increase the micro stepping, so then it won't vibrate that much, but then I'll lose torque. So for a moment I'll leave it on vibrating. Well, let's just see. I can maybe show you the difference. Is it currently on micro stepping? No, is it? Shit, it looks dodgy over there. Oh, it looks super dodgy. No. Okay, it is on micro stepping, is it? Shit. Yeah, it was on micro stepping. That's without micro stepping. Okay, I think I overdid it. But that looks quite good actually. I'm actually quite impressed. I didn't expect that to, well, get it down quite that much. So, I mean, the diameter size, I mean, if you look at this is probably a bit too small now. So let's change the micro stepping again. Let's put it on, what, one micro stepping. Okay, so now it will be a bit thicker, but okay, I mean, I've got a speed changer to adjust the speed. That's what I should be using. So micro stepping is to remove vibrations from the whole system. But I mean, I'll still fine tune this, not a problem. It looks good. I mean, shit, look at that. That doesn't. I don't see any bubbles. I don't see any deforms. I see a lot of white mixed in there. So it might be deceiving me that those are bubbles and not actually just the white filament mixed in there. But I moved the food. I'll need to secure the that. I'm happy with the solution. So far, so good. Let's see, and this is the filament that I'm creating right now. So it goes down there. This is actually the best so far. I'll probably need to measure the speed of this as well. But that's just from since I turned the video on basically, and it's what 3 minutes at this point. So I'm quite excited with that. It looks good. I'll probably be able to print it. I want to measure that. Maybe I can measure it. Hopefully you guys can stay with me like this. Okay, I'll be back now. I guess I won't be. Okay, so far this thing has a really good consistency. I've changed it now, so it might differ now, but let's just see. It's roughly about 1.3 millimeters at this point. I did change it though. I mean that's roughly what it is. So I did adjust it to be bigger now, so it should be going slightly bigger, which I'm impressed with. It's just tuning it finally. Well, it should be 1.4 now. I mean, it should be consistent. I'll probably I need to decrease the speed to let it go even more. As you can see, it's 1.3 basically, 1.34, 1.3, 1.26, 1.28. So definitely good. Well, I think usable, but I need to get this thing to be a bit thicker. So let's see, can we do it at this point? Probably not the best point to do it because I might mess up the whole. 1.8 well, it looks like it might be different. Let's try it over here. Sorry, I'm all over the show. I need to really get something to a third hand. So it's a 2, 1. No, was it a 2? I might be measuring it incorrectly. So I'm at an angle and this thing is moving forward, so it's going to bulge up. Shit. That's still too small. You see, because I bulged it up, I can see there's a little dot. Oh, yeah. Should see what come out now. There you go. But okay, I'll fine tune this, get it to 1.75 and see if I can maintain it, or you know what the tolerance level is at that point. But so far it looks good. I mean, this is all the filament for now. And this is basically 5 minutes worth of filament maybe. So it looks good.